Good morning. In this session, we evaluate the large-scale extraction of sulfur through the process referred to as the Frasch process. Welcome. Now, the Frasch process, as mentioned, is a process for the large-scale extraction of sulfur. Sulfur is a naturally occurring inorganic substance underneath the Earth's surface at around 200 meters below the crust. In order to reach the layer of sulfur underground, 3 concentric pipes are lowered into the position where sulfur is found, that is within the ground. Now, to be able to extract sulfur from that position of 200 meters underground, a series of technical processes are introduced within the 3 concentric pipes. First, the 3 concentric pipes are of diameter ratios of 3:5:8. Namely, the innermost is 3 centimeters in diameter, the middle concentric pipe is 5 centimeters in diameter, and the outermost is 8 centimeters in diameter. Now, this represents a dynamic shift in radius from the smaller to the medium to the largest. Now, in order to reach the sulfur deposit, superheated water at 170 degrees Celsius and 15 atmospheres of pressure is pumped through the outermost concentric pipe in order to melt down the solid sulfur underground. Once the solid sulfur is confirmed melted, hot compressed air at 10 atmospheres is forced along the innermost concentric pipe in order to compress the surface of molten sulfur and push it upwards along the middle concentric pipe. Therefore, the molten sulfur rises along the middle concentric pipe and is collected at the top as a molten sulfur extract. Now, this molten sulfur extract soon solidifies into plastic sulfur. And sulfur, as known, has a varied range of states, in the sense that when in molten state and exposed to air, it becomes plastic. But then, when you subject it to heating, it manifests into different range of colors in a process referred to as the flowers of sulfur. Let's look at this briefly. As illustrated down here, you may see that sulfur is a packed ring of 8 sulfur atoms. In other words, there are 8 sulfur atoms which are conjoined in a network of a packed ring akin to what you can see there as the amber yellow sulfur. Now, this solid has a melting point of 113 degrees Celsius, and in that case it's in the form of rhombic sulfur. When it melts, it forms a viscous liquid with a continuous chain of sulfur atoms, which may be in the range of 10:2, 10:5, 10:10, and so on. So the replication of the sulfur atom chains form a long continuous chain which becomes viscous liquid, and the color darkens from what initially was bright or amber yellow into pale yellow. Continued heating of the viscous liquid at roughly 200 degrees Celsius reduces the viscosity or the turbidity of the liquid, and it becomes semi-viscous, and the color becomes even darker brown. Continued heating to a temperature of approximately 400 degrees Celsius transforms the semi-viscous liquid into a dark gas which appears as a black vapor. Now, this black vapor, with continued heating, we find that the actual boiling point of sulfur is 444 degrees Celsius. And at that point, the black vapor transforms into a brown gas which is very active, and this is the ultimate form of gaseous sulfur state. When this gaseous sulfur is condensed or cooled, it undergoes sublimation directly from gaseous into solid state and comes back into a network of 8 sulfur atoms forming the packard ring of amber yellow sulfur as illustrated there. So these dynamic processes by which sulfur changes its form, its nature, and color is referred to as the flowers of sulfur. Otherwise, we will also refer to the amber yellow sulfur deposit through sublimation process as the flower of sulfur. Therefore, we can conclusively say that sulfur is a solid substance that naturally occurs underground, approximately 200 meters below the Earth's surface. And to be able to extract sulfur, we use the Frasch process, in which there are 3 concentric pipes of diameter ratios 3:5:8 centimeters. The first procedure in the concentric system is the downward passage of superheated water at 170 degrees Celsius and 15 atmosphere. Remember, water boils at 100 degrees Celsius. So at 170 degrees Celsius, the water is actually vaporized, and the 15 atmosphere pressure is to liquefy it. In other words, to turn it back to liquid form so that it can effectively be able to melt down the solid sulfur on reaching it. The next procedure after passing down the superheated water to melt the sulfur is that of passing down hot compressed air. This hot compressed air is at 10 atmosphere, sufficient enough pressure to push down the molten sulfur to rise along the middle concentric pipe and collect at the top as an extract of molten sulfur. We have also said that this molten sulfur, when left exposed to air, soon becomes plastic, and we refer to it as plastic sulfur. We have also evaluated what happens when sulfur is heated, and we have said that the nature of sulfur is that it is a packard ring of 8 sulfur atoms, which when heated will melt at 113 degrees Celsius. The color changes from a bright yellow or amber yellow into pale yellow, and the solid is translated into a viscous liquid. Continued heating reduces the viscosity, and it turns into brown color with semi-viscous liquid. The semi-viscous liquid will again vaporize. It will begin boiling at around 400 degrees Celsius, but evaporates at 444 degrees Celsius, and the color changes from dark black into brown gas, which is active sulfur gas. The active sulfur gas then undergoes condensation, and through the process of reverse sublimation forms back the original packard ring of 8 sulfur atoms, which is amber yellow in color. Thank you. That is a description of sulfur, its extraction, and its varied forms in its flower characteristics.